Hey everyone, I am Wish and today I want to show you something very cool, my anime recommendation system. If you ever struggle to find your next anime to watch, this project is here to help. Let's check it out.
So first, I'm here in my anime repository to show you how I built this anime recommendation system from scratch. The first step was dealing with a messy dataset, so I uploaded 3 Jupyter notebooks. The first 2 notebooks handle EDA, exploratory data analysis, and data filtering, while the last notebook is dedicated to the recommendation algorithm. Now, let's start with the first notebook, where I clean the messy dataset. First, we import the necessary libraries and read the data. As you can see, the dataset is quite messy, so we need to remove duplicate values. After running the function, we successfully remove a lot of duplicate rows. Next, we need to eliminate useless columns like links, member ranks, and some other unnecessary data. These columns do not contribute to the recommendation system, so removing them helps in making the system more efficient. Now, let's fix the aired column. This column contains the full date range of when an anime aired, but for recommendations, we only need the starting year. So, I created a function that slices each row in the aired column, extracting only the starting year, like 2001 or 2007. This helps us categorize anime by release year, making recommendations more relevant. Now, we need to remove old anime before the year 2000 since they may not be relevant for most users. I manually filter out older dates using the aired column. Also, we need to remove hentai from the dataset because hentai is not considered mainstream anime for recommendations. The next step is to remove low-rated anime to reduce the dataset size and improve the recommendation quality. We also need to modify the score column, which contains floating point values like 3.0, 5.5, or 7.3. I created a function to round these scores to whole numbers like 3, 5, or 7, 7, making the data more uniform. Finally, I removed anime with ratings between 1 and 4, as they are generally not recommended. After filtering out unnecessary rows, our dataset is now much smaller and more optimized for building the recommendation system. Now it's time to build the recommendation algorithm. I'm here in my last notebook, and since some steps are the same as in the second notebook, we won't cover them again. Let's jump straight into it. First, I read the filtered CSV file. This dataset contains a new unwanted column named unnamed:0, so I remove it immediately. Next, I check the dataset's structure using the info function and look for null values. It turns out we have some missing values in the synopsis column. For better accuracy, we need to remove outliers and handle NaN values. To do this, I replace all NaN values with the string unknown so that the model doesn't encounter missing data issues. Now I convert the episode and popularity columns into strings, since treating them as numbers won't be useful for recommendation purposes. Next, I create a new column called tags. This column combines multiple important attributes like genre, synopsis, aired date, episode count, and score into a single text format. By merging these key features, we make it easier for the recommendation model to compare anime. After merging, we need to split the words in the text columns to ensure proper tokenization. We also replace brackets with dashes to clean the formatting. While reviewing the dataset, I noticed that 347 rows in the score column contain unknown values. These might not be useful for recommendations, so we need to handle them carefully. Next, I create a copy of the dataset named df and join all words in the tags column using the join function to ensure consistency in text processing. Now let's normalize the text for better model accuracy. This includes converting all text to lowercase and ensuring uniformity. After this, I replace names with dashes in the text column to standardize the format. Now, we move on to the bag of words model. If you're unfamiliar, the bag of words approach converts text into numerical feature vectors by counting word occurrences. To apply this, we use NLTK's Porter stemmer, which helps reduce words to their root form stemming. This ensures that similar words like comedy and comedies are treated as the same. Now I import a library called Count Vectorizer, which transforms text data into structured numerical features. Using Count Vectorizer, we fit and transform the tags column into an array, extracting all unique words as features. You can see the generated feature names here. The final and most important step in our anime recommendation system is implementing Cosine Similarity. Cosine Similarity is a metric that measures how similar two documents, or in our case, two anime, are based on their word vectors. It calculates the cosine of the angle between two vectors in a multi-dimensional space. If two anime have similar genres, descriptions, or other features, their vectors will be closer together, meaning their cosine similarity score will be higher. For example, if we compare two anime like Sword Art Online and Log Horizon, they might have a high similarity score because they share genres like action, adventure, and virtual reality. However, if we compare Naruto and Your Lie in April, their similarity score will be lower since one is shonen action and the other is romance drama. Now, let's import the cosine similarity function and apply it to our dataset to find the most similar anime for each title. Now that we have our similarity matrix, let's move on to the function that retrieves recommendations based on user input. Finding the anime index. The function first searches for the index of the anime entered by the user using fetching similarity scores. Using the index, we retrieve the similarity values for that anime from the cosine similarity matrix. Sorting the similar anime. We sort the list of anime based on similarity scores in descending order. The enumerate distance pairs each anime with its similarity score. Sorting is done using reverse equals true to prioritize higher similarity scores. The 119 ensures we skip the first entry, which would be the input anime itself, and return 18 recommendations, printing recommended anime titles. Finally, we loop through the sorted list and print the titles of the recommended anime. With this function, whenever a user enters an anime title, the system will return 18 similar anime recommendations based on cosine similarity. This makes it easy to discover new anime that match the user's interests. As you can see, this recommendation function output is too great. We got popular names. Now, it's time to finalize our anime recommendation system. We have built the recommendation algorithm, optimized our dataset, and implemented Cosine Similarity to find the best anime matches. The next step is saving our model so that we can use it later without having to recompute everything from scratch. To save our data and similarity matrix, we use Pickle, a Python library that allows us to serialize and... However, our Pickle file is too large to be deployed on the cloud. To reduce its size, we use BZ2 compression. This will make deployment easier and reduce storage space. Now our anime recommendation system is ready. The next step is to build a web app and deploy it, so users can input anime names and get recommendations instantly.
Now it's time. I'll walk you through the complete anime recommendation system web app that I built using Flask, Pandas, Scikit-learn, and web scraping with BeautifulSoup. By the end of this video, you'll understand how this system takes an anime name, finds similar anime, fetches details, and displays everything on a web page. Let's dive into the code and break it down step by step. Before we start building the system, we need to import some essential Python libraries. Let's go through them one by one. Count Vectorizer from sklern.feature_extraction.txt. This library converts text data into numerical form. We use this to transform anime descriptions into a format that our model can analyze. Cosine_Similarity from sklearn.metrics.pairwise. This function helps us compare anime based on text features like genre and synopsis. The higher the similarity score, the more alike two anime are. Flask and its modules. Flask is a Python web framework that helps us build a website. We use render_template, request, JSONify to display web pages, process user inputs, and return recommendations. Anime and anime search from the MyAnimeList API. This allows us to fetch anime details like title, score, synopsis, and genres directly from MyAnimeList. Requests and BeautifulSoup. These help us scrape user comments and trailers from anime pages on MyAnimeList. Pickle and BZ2. Pickle is used to save and load pre-computed data so we don't have to process it every time. BZ2 is a compression tool that makes our Pickle file smaller, making it easier to deploy on the cloud. Next, we initialize the Flask application and load our dataset. Initializing Flask app. This starts our web app. Loading the dataset. This file contains anime titles, genres, descriptions, and scores. Loading the compressed similarity matrix. We use BZ2 to load our Cosine Similarity matrix efficiently. Python file. This allows us to find similar anime quickly when a user searches. The home route defines the homepage URL. Search suggestions are read from a list of anime titles. The homepage displays a search bar where users can enter an anime title. To make the recommendations more interesting, we fetch user comments and YouTube trailers using web scraping, fetching anime details using BeautifulSoup. This opens the anime's MyAnimeList page and extracts details. To make the recommendations more visually appealing, we also fetch anime posters, genres, scores, and aired dates from MyAnimeList. Using the MyAnimeList API to fetch details. Now let's talk about the most important part, recommending similar anime using Cosine Similarity. The user enters an anime title. The system finds the anime's index in the dataset. It compares the anime to others using Cosine Similarity. The top 10 most similar anime are selected and displayed. Finally, we run our Flask app so users can interact with it in real time. Python. Now I'll explain the two most important folders in a Flask web application, the templates folder and the static folder. These folders are essential for building a fully functional web app. Let's break it down step by step. The templates folder is where we store all the HTML files used for rendering web pages in Flask. Instead of writing raw HTML inside Python code, we separate the front end by storing these files inside the templates folder. Flask uses render_template to load HTML files from the template/folder. It supports Jinja 2 templating, which allows us to insert dynamic content like anime titles, recommendations, and user inputs. Now I'll explain how our Flask web app uses three important HTML files: home.html, index.html, and error.html. Each of these files has a specific purpose, and together they create a smooth user experience for our anime recommendation system. First, we have home.html, which is the main page of our website. This is where users enter an anime name to get recommendations. What happens here? A search bar allows users to enter an anime title. A submit button sends the anime name to the Flask backend. The page is styled using CSS from the static/folder. When a user submits their search, Flask processes the input and redirects them to index.html, where recommendations are displayed. Next, we have index.html, which is the page that displays anime details and recommendations based on the user's input. What happens here? The selected anime's name, image, and description are displayed. A list of recommended anime is shown, each with a poster and title. The page may also include YouTube trailers and user comments fetched via web scraping. If a user enters a valid anime name, this page provides useful recommendations, helping them discover similar shows. Finally, we have error.html, which is displayed when the user enters an invalid anime name or if something goes wrong. A message appears saying, "Anime not found, please try again." Now move to the static folder. The static folder is used to store CSS, JavaScript, images, and other assets that do not change dynamically. Unlike templates, Flask does not process these files, it simply serves them as they are. The static/folder contains files like style sheets, JavaScript files, and images. We reference these files using the function in HTML. I'll explain how we use the static folder in our Flask web app. This folder contains essential files like style.css, script.js, and background images that help make our anime recommendation system look great and function smoothly. In Flask, the static folder is used to store all the files that do not change dynamically, such as style sheets, JavaScript, and images. Unlike the template folder, which contains dynamic HTML, files in static are served directly to the browser. What's inside the static folder, style.cs, defines the look and feel of the website. Script.js adds interactive functionality, background images, enhances the design and user experience. The style.cs file is responsible for making our website visually appealing. It controls colors, fonts, layout, and animations. What does style.css do? Styles the homepage, home.html, making the search bar and buttons look attractive. Formats the results page, index.html, ensuring anime details and recommendations are well organized. Designs the error page, error.html, displaying friendly messages when an anime is not found. Applies background images, ensuring the website looks engaging. Without CSS, the web app would look plain and unstructured. By linking style.css in our HTML files, we ensure a smooth and modern design. The script.js file adds interactivity to our web app, improving user experience with animations, pop-ups, and dynamic content updates. What does script.js do? Handles form validation, ensuring users enter a valid anime name before submitting. Manages animations such as hover effects on buttons and search fields. Dynamically updates content, like fetching new recommendations without reloading the page. One of the most important parts of our web app is providing live anime title suggestions as users type in the search bar. This is done using AJAX in script.js. How does AJAX work? User starts typing in the search bar. AJAX sends the input to the server without refreshing the page. Flask processes the request. It searches for matching anime titles. Suggestions appear instantly. The matching titles are displayed as a drop-down list. Images in the static folder are used to make the website look visually appealing. And that's how our anime recommendation system works. Now it's time to host our web app. Before we go to Heroku, we need to prepare our project by creating two important files. Procfile tells Heroku how to run our web app. Requirements.txt lists all the Python libraries our app needs. Once these files are ready, we upload all our project files to GitHub. Now let's move to Heroku. I've already deployed my anime recommendation system, so I can't show you the login and setup steps in real time, but I'll explain the process. First, log into Heroku. Heroku will ask you to select a programming language, choose Python. Then, create a new app and choose a server location. Next, connect your GitHub repository to Heroku. Finally, click the deploy button and Heroku will handle the rest. And that's it. Your web app is now live on Heroku.